going to have the computer read this to you, but in short, what you have to do is design a solution. Designing does not mean doing. Designing means what do you intend on doing. So you need to create a plan for what you're going to do next.
Instructions for students. You must complete the activity within the assessment. The task must be undertaken at the time and on the date specified by Pearson. You will be given 3 hours for producing the outcomes for this task. Your center will advise you of when any supervised breaks have been scheduled. The task must be completed under supervised conditions. You are not permitted access to the internet during this task. You are provided with the file task_3_data.csv for use during this task. Your work and any material provided must be kept securely at all times. Set task brief. Part of the new digital solution requires your company to develop a data service that will turn raw data into meaningful information. The information will be used by the client to make data-driven decisions. Your manager has decided to open the problem up to all developers to see if they can design a suitable solution. Your manager has provided you with a set of requirements that he has agreed with the client. Activity. You must produce algorithm designs to show how you would implement the system and user requirements provided in the set task information. The algorithm designs should be of sufficient detail to effectively communicate the intended solution, allow the client to make informed decisions, allow a third party to use the design documents to create the proposed solution. You should use either pseudocode or flowcharts to communicate your algorithms. The file task3_data.csv contains an example of the data that will be used by the solution. You should use this file to help you design your solution. 17 marks. Save your completed design documents as PDF files. All files should be saved in your folder for submission. Use this naming convention. Set task information. The solution must allow users to select a destination and compare the pricing of flights from different airlines to that destination for the specified period of time. The solution must also be easy to use, display information in a meaningful way, make use of appropriate textual, numerical and graphical output in a way that would be relevant to the end use.
When you get a copy of the mark scheme, I think the section that everyone needs to go through as well is this section at the very top of each part that says indicative content and marker guidance. What that means, this is what the examiner is going to be looking for. So these bullet points here are what the examiner is going to be looking for. So if you have these in your exam, in your work, you're kind of guaranteed to get the marks if you fulfilled enough of those requirements. For the assessment focus this time, we have 3 sections. The first section is going to be decomposition of the problem. We have a maximum of 8 marks. We have application of logical thinking and conventions. We have a maximum of 6 marks. And finally, we have communication of the design, a maximum of 3 marks. Now, I know what everyone might be thinking right now. I see the word input, I see the word process, and I see the word output. So it must be a flowchart. And you can use a flowchart, but you don't have to use a flowchart. This very first section that says decomposition of the problem, it can just be a decomposition diagram. This is not something that's very common, I know that, but it can just be. If I scroll up to this section here, this is a decomposition diagram. I'll zoom in, but you can all go and download this entire thing completely for free using the first video I uploaded. So this is a decomposition diagram. This just shows what is going to be done, but it doesn't have any of the traditional flowchart symbols like input, output, process, storing data. It doesn't have any of that stuff. It just has some boxes with some descriptors. That's it. So you think about what needs to be done, read the scenario again, think about what needs to be done, think about what you need to do from your end as a programmer, as a developer, as a designer, and that's what you put in these boxes. I'm not going to go through the boxes. What I'll do, I'll scroll down. If you want to see what's in the boxes, simply pause the video, read it, and it should make perfect sense. So if I go over the descriptors quickly, it says basic or superficial decomposition. So that's if you have some of the basic stuff that needs to be done for this solution. Next, we have mostly detailed decomposition. So if you've done most of the things, so you have your criteria, you have your requirements, let's say. If you have most of the things that need to be completed on there, then you should be good to go. Now, the last one is going to be thorough and detailed decomposition. Thorough and detailed decomposition needs to have inputs, processes, and outputs. But I repeat, I stress, this does not have to be, even though it can be, this does not have to be a flowchart. I would highly recommend using a simple basic decomposition diagram like the one I showed you before, just to crack it out, get it done quickly, and then move on to the next section. Next, we have application of logical thinking and conventions. This is a section where you actually need to do a flowchart, or you can do pseudocode. You do not need to do both of them. One is perfectly fine. And personally for me, I would probably do pseudocode, because pseudocode is simply going to be a description of what you need to do. If you get the symbols wrong in a flowchart, it's wrong. It's very hard to get the description of what needs to be done in pseudocode. Once you get those keywords like input, process, output, save, end, start, then pseudocode becomes very, very easy. I'm going to scroll up to the one that's in the mark scheme here. This is not the only way to do this. This is just one of the ways that you can do this. And you need to keep in mind when you're designing your solution, each section, you need to decompose the problem. So your decomposition diagram earlier, this breaks the problem down into smaller sections. When you're doing your pseudocode or your flowchart, you need to do pseudocode or flowchart, different ones for different sections. For example, if I zoom in here a bit, this one is menu, get and validate destination. So that's the first thing for this specific one. You don't just do one massive flowchart or one massive piece of code for everything. You break it down into smaller steps and you differentiate them. So this one is getting and validating destination. This one is getting flight data. The last one over here is going to be find and output most and least expensive. So whatever your problem is, think about what your specific problem on your exam paper is. Once you've broken it down in your decomposition diagram or your flowchart or whichever way you decide to break it down, once you've broken it down, you then break it down further in pseudocode. So here in your decomposition diagram, you simply say the thing that needs to be done or say how it needs to be done. But down here in your pseudocode or flowchart, that's where you detail as much as possible within reason. It doesn't have to be Python code or Java code. Just detail as much as possible what needs to be done, where you need to get data, send data, display data, save data. That's what this section is going to be about. The things that they're looking for this section is precise logic. What does that mean? It means when you trace the logic or when you trace whatever you've done in your pseudocode or flowchart, it should make sense. It should give you some sensible output. It should work in theory. Obviously, it's nothing practical. It's only a theoretical thing. So you should be able to follow it and say, oh yeah, that is going to output 1. That is going to output 0. Whatever it is, it should make sense. Next, we have appropriate and efficient structure and sequence. The structure of something is how it is made up, how it is built. The sequence is whether it can be followed well enough. So efficient structure means that you're not repeating yourself constantly, right? You can create a function using pseudocode or flowchart that you can go back to. So you don't have to say, okay, get name, get age, get this. You can simply create a function at the very top that says, for example, get details. And whenever you need to refer to that function, you simply refer to it or go back to it or draw a line to it. And finally, we have appropriate and consistent use of accepted conventions. The conventions are, how is this normally done? That's what the word convention means. How do people normally do this? Appropriate and consistent. Consistent means you're always doing it. Appropriate means, is it correct for this specific scenario? What does that mean? That means if you're getting input from someone, if it's pseudocode, you should have the word input in front of whatever the description or the thing is going to be. If it's a flowchart, you should have the input symbol for flowchart with your descriptor inside of that. So whatever thing you're doing, so we have input, process, we have output, we have start, end, whatever thing you're going to be doing at the time, use the appropriate symbol or name and then give your descriptor. Finally, we have communication, and this one again only gives us 3 marks. I'm going to skip straight to the third one. Effective communication of design uses technical language which is appropriate for the audience. The people that would read a pseudocode or a flowchart are going to be developers, programmers, people who understand that stuff. You're never going to give a flowchart or a pseudocode, especially a flowchart of this complexity, to someone who has no idea about programming or anything of the sort. So what does that mean? That means the symbols and the words and the shapes and everything you use needs to convey the information so clearly that when you hand this over, because remember, you're a designer, you don't do anything as a designer other than write on paper or give someone a diagram or give someone a description of what needs to be done. This description that you've created, being either the flowchart or the pseudocode, whenever you give it to someone who's going to be, in this case, a developer or programmer, whoever, when you give this person your description of the system, they should be able to follow those instructions. And again, it doesn't have to be perfect across the board. You don't give them something and they can just go ahead and create it by themselves. But ideally, that's what it should be. So in an idealistic world, you should be able to hand them this document, this image, this drawing, this description, and they should be able to go away, follow those logical instructions and say, okay, yeah, I know how to do this thing with the data I have. I know how to do this. I know how to do that.